Hello, everyone. Thank you for joining us today as we come together to learn more about using Dapr with microservices. My name is Hussam Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Ovais Mehboob. Ovais is a senior customer engineer development at Microsoft with more than 15 years of experience in the IT industry. He worked in various roles, including software engineer, technical lead, solution architect, and consultant. He's a former 5 times Microsoft MVP and delivered various technical sessions and events on Microsoft and OSS technologies. He is also a prolific writer and author few books titled JavaScript for .NET Developers, Enterprise Application Architecture with .NET Core, and also C# 7 and .NET Core 2.0 High Performance. Feel free to ask questions during the session. We will have regular stops to answer these questions, and also feel free to tweet about the session and tag us on the Twitter hashtag Reactor Abu Dhabi, and MSFT Reactor is the Twitter handle. And with all that said, I hand over the mic to our speaker to start the session.
Thanks, Osam. Thanks very much for the introduction. Let me share my screen. Okay, guys, first of all, thank you very much for joining this session. So in today's session, we'll be talking on using Dapr with microservices. Dapr is getting a lot of traction in an open source community, and especially when we are building microservices based applications. It aims to simplify creation of resilient and portable applications. So in this session, we will be focusing on the basics of Dapr, its building blocks, and how to use in microservices architecture. As Sam mentioned, I'm Ovais Mehboob and I'm a senior customer engineer in development at Microsoft. I have around 15 years of experience in this industry. I've served as 5-time Microsoft MVP on developer tools and technologies, and I have also written a few books on .NET, Enterprise Application Architecture, and JavaScript. You can always reach me out on Twitter. So this is my Twitter handle at Ovais Mehboob if you wanted to connect me on Twitter. So today the agenda is we will be first, before jumping to the Dapr, I will give you a brief introduction to microservices architecture. The reason is maybe there are a few new people here in this session who does not have much experience or understanding about microservices architecture. So I will put some time on microservices architecture, what microservices architecture looks like, what are their benefits, what are its challenges, and how we can map those challenges using Dapr. In the second section, we will discuss some what Dapr is, what are key building blocks, what are Dapr concepts, and how we can use those building blocks in microservices applications. We have some demos as well throughout this session. We will also discuss the overall architecture about Dapr, then the developer frameworks that it provides, and then finally, when we talk about microservices, so we cannot just skip mentioning the name of containers. So if we wanted to deploy our microservices on any container orchestration platform such as Kubernetes, so how we can run Dapr there. So we will see what are the necessary configuration need to be done in order to make your application, which is running as a Dapr on Kubernetes container orchestration platform. During the session, if you have any questions, you can just write it on a chat window, and I will be taking questions after every few 15-20 minutes, and I will try to answer them right away. Okay, so let's talk about what microservices is. So in microservices architecture, your application is actually decomposed into set of various fine-grained, or you can say small services that are more modeled towards a business domain. Ideally, each service has a separate database that contains respective domain-specific information. For example, if you talk about as compared to the monolith applications, what we have one single hosting process. However, we can use some layered architecture approach and just to decompose our application into different layers, where we have one presentation layer communicates to a business layer, where we have the core application logic, and that business layer communicates to the data access layer to perform some CRUD operations. With microservices, we actually decouple our application horizontally and vertically into set of different services. So in order to decompose or transform your existing monolith into microservices, you first have to identify what are the business capabilities or what are the business domains. And based on that, you actually split that application into set of different services. However, the front end is normally the same front end. It's a one single application which is communicating to all those services. Now, with microservices architecture, these services are actually following the REST API principles, in which basically expose a RESTful endpoint, which can be used by your front-end application, right? And they all communicate over a lightweight protocol such as HTTP. So there are certain challenges as well when you are decomposing your big monolith application to set of different services. So sometimes the challenges are like if your transaction spans to multiple services, now each service having a separate database as well. So how you will maintain consistency across different database. And with microservices, there are some benefits. As for example, you can, for example, you have 4 or 5 services, you can choose any technology as you wish. So for example, one service is you choose .NET Core as an underlying technology to build a service. Another service could be on Java, another one could be on Go language, Python, and so on. And each of them can hold separate database based on the scenario, based on the need. So maybe your first service is storing data in NoSQL database, the second service is storing data in a flat schema on Azure Cosmos DB, and maybe the third service is storing data in relational database. So how you can maintain transactions? So there are certain patterns that can be used in order to maintain consistency across databases. When we talk about microservices, so microservices is one of a characteristic of cloud native application. When we say that our application is cloud native, so it should adhere to 4 principles, or you can say 4 pillar. That is microservices architecture. Like your application, if you are saying that okay, your application is cloud native, so that means it is complying to microservices architecture. You should have a container infrastructure support, right? So when we are building microservices, so we of course we want an isolated space where we can run our application in a sandbox environment. So you need to containerize that application to run it, to scale out, and to get benefit from the containers, right? Then you have to have DevOps in place for complete application lifecycle management, and for deployment, you need to have a continuous deployment, because with microservices architecture or with microservices application, manual deployment is not a viable option. Because, for example, if you have a big monolith application and you split that application to a set of 25, 30 services, you would not be easily deploy them manually. So you need to automate the deployment as well. These 4 characteristics basically are which are basically specified by CNCF, which is a Cloud Native Computing Foundation, which says that if your application is cloud native, it should have these 4 characteristics built in. What the challenges developer face. So first thing, the challenge developer face with microservices application is learning curve. So they have to, for example, right, you are experienced developer and working on you have experience working on monolith applications. So for example, you started with some application on .NET Web Forms a decade back, and today you wanted to use some new technology, you wanted to use some open source technology. So it's not easy to introduce new technology, because your application is quite big. It's very difficult to change that application. So with microservices, what happens today, because each service is representing one business capability or one business domain. So when you are working on a new domain, you can easily introduce new technology. Or for example, if you started with, for example, Python some time back, and now you wanted to replace it with .NET Core, you can easily replace it because it only affects one particular part of the application, not the whole application. So developer face, there is a huge learning curve on the developer. They need to improve their skill set, because with microservices architecture, they are getting this chance to add new technology, so they have to upgrade themselves. But sometimes on the when you started working on those or writing that service on those particular languages, sometimes that language does not provide a wide range of libraries. So for example, in order to implement asynchronous communication across services, you may ended up using event hubs over Kafka protocol to implement publish subscribe model, in which if service A wanted to communicate to service B, they can publish a message to the event hubs over Kafka protocol, and then the subscriber or the consumer who is listening to that queue can read that message and then perform whatever work it needs to be performed, right? So in this case, maybe your Python service wanted to push something to the Kafka topic, and that library is not available. So this is one of the challenge that you can face as well, because those languages does not have a wide range of libraries to communicate with some cloud services or on-prem services to implement certain patterns. So this is where Dapr actually solves these kind of challenges. Just to clarify, just to have more better understanding about what microservices architecture looks like. So considering this example, it shows 3 microservices and a front-end application. All of them are based on different technologies. For example, the card service use Redis cache to store card information. The order service use Cosmos DB, and payment service use MySQL. There is a front end which is built in React Native, or you can say React language. And if once the user come to the website, he can actually search for products, add it to its cart, and once he take that action, the service is invoked by the front-end application to save that card information or save that item information into Redis cache. Now he decided to go with the payment, so he can go and purchase items where he will get a page to specify his credit card details and other payment information. Once he proceed with the payment, and once the payment is successful, the payment information will be saved in the Azure SQL database, and then payment will create an order. So in this case, payment service can directly communicate to order service over HTTP, or if you want to implement asynchronous communication, because sometimes it may be your order service is not running up, its order service is down at that time, so your payment service will fail. So in order to avoid this failing scenarios, we can implement async communication, and we can go with pub sub messaging, where your payment services publish an event to Azure Event Hubs over Kafka, and your order service will actually subscribe to that topic. So once the event published by payment service, the order service will read that event or read that message and perform some work to save to create an order and to save the order information in Azure Cosmos DB. So this is a schematic representation of a sample e-commerce site which is based on microservices architecture. So this is what microservices architecture looks like. Now, how Dapr solves these challenges? So basically, Dapr is a tool that runs as a sidecar with microservices-based application. It provides a runtime, which is portable, event-driven runtime for building microservices application. You don't need to use event, like it's something which can attach with your application as a sidecar, and then you can communicate to Dapr using different protocols. Like you can communicate to Dapr sidecar, like your primary application is running on a separate host process, and there is a Dapr sidecar, which is a separate instance connected with your application, and your application can consume those building blocks which Dapr offers to provide to store something in this state, to provide event driven messaging, to publish message, to implement pub sub messaging, to send some log tracing to some application inside or other sources. And there are around 7 building blocks so far which Dapr offers, and your application can communicate to those building blocks over an HTTP API. And this is not the only API. If you wanted to go with gRPC API is also supported. And not only this, Dapr also offers you an SDK that you can use to communicate with those building blocks as well. The goals of Dapr, it provides best practices building blocks. So it provides building block that we'll be talking about shortly in this session. You can integrate with any language or framework. So today you are using Python and you wanted to send a message to Kafka, and you ended up having no library to send a message to Kafka topic. You can easily integrate Dapr and configure those building blocks. So it's basically run on a configuration driven system where you can define the component, you configure all those connection strings, and then you just consume a simple HTTP RESTful API to use that building block. And we'll be see like how easy it is to use any of these building blocks. It's a community driven vendor neutral framework that it was started in October last year, and we have more than around 145 contributors so far. And even if you wanted to participate, it's an open source thing. You can go to GitHub and you can participate there as well. It's on open standards, open API specification. All these APIs are basically consumed over a RESTful endpoint. It's platform agnostic, so you can run it on cloud, edge, or on-prem server. Like I can show you the demo today on my machine, and I have also hosted one container running on Kubernetes on cloud on AKS. So you can run anywhere as you want, and it also provides you some pluggable components that can be attached to a service or application. So this is what Dapr is. So Dapr actually provides best practices for building microservices application into open, independent building blocks that enable you to build portable applications with the language and framework of your choice. Each building block is completely independent and you can use any of them based on your need. It's not necessary that you need to use all of these building blocks. If, for example, you want to invoke one service, you can go with the service to service invocation building block. If you wanted to store some state, you can go with state management. If you wanted to implement publish and subscribe model, you can use that publish and subscribe building block as well, right? And they communicate. So this is your application code. It could be on any framework or language: Golang, Node.js, Python, .NET Core, Java, Objective-C, whatever it is. You can communicate to this building block. So it basically, this is your sidecar. So this is your application which is running in a separate instance, and this is your sidecar. And your sidecar basically, this Dapr runtime is providing you these building blocks, and no matter to which particular source you want to connect to. So instead of your Node or Python app communicating to Azure, AWS, or Google Cloud, you are basically using HTTP API of Dapr to communicate with any of these sources. So for example, today I'm using Azure and I provision Azure Event Hubs to go with Kafka protocol, or I'm using RabbitMQ somewhere on AWS or any other cloud platform. So I don't need to use that library inside my application. I can make my application clean from all those libraries and stuff. I'll just add Dapr. I'll just start my application with Dapr runtime, and I can use any of these building blocks to connect with any sources. And of course, you need to configure that building blocks in prior using those services, and that configuration is all imperative. Like you can just it's declarative. Basically, you can specify that YML file, and you specify all those connection strings and all to connect to any of these sources. So just to summarize, Dapr supports all programming languages via HTTP and gRPC. It's a multi-cloud open components, provide a lot of bindings, lot of building blocks such as bindings, pops up, state, connect to any sources such as Azure, AWS, Google Cloud Platform. It can run anywhere as a process or containerized. It's very lightweight runtime, 58 MB of size, and takes hardly 4 MB physical memory. Runs as a sidecar. So it's something not directly embedded into your application. It runs as a sidecar. So remove the need of special SDKs or libraries. It also offers a dedicated CLI. So you can just spin up your application with Dapr runtime using Dapr run. And we will see that in the demo shortly. And you can also use, so for example, if you're not comfortable in using HTTP API or gRPC API, or basically it provides you another few other patterns such as actor service pattern, which is one of the design patterns used in microservices. So if you wanted to enable that, implement that pattern, so you can use Dapr SDK as well. And Dapr SDK is available for Java, .NET Core, Go, JavaScript, Python, Rust, and C++ languages. So just to see how it works, so for example, you see that there are two endpoints. So this is the standard URL pattern, or you can say the endpoint to invoke any of the building block. So from your application, if you wanted to connect to your sidecar instance, you have to go to localhost, because of course it's currently running in the same server. So even if you are deploying it in Kubernetes, so you have one pod, within one pod there are two containers running. One is your application container and the other container is your sidecar container. So you can always communicate over localhost with this particular Dapr instance. And then this is your port. It could be dynamic port. If you don't specify any port, you can also change this port as well while running this. This version 1.0 is your API version. So currently the version which is the current version of Dapr is version 1.0, and this state is your building block. This state means that I'm using state management. So that means I wanted to save some key value pair in any of the source which is connected or configured with this state management. So for example, in order to use this state management, I'm using Redis cache. So I just have to configure that component in my application, and I can just invoke this particular building block using this endpoint. So this is my localhost 3500, which is my Dapr runtime is hosted at, and version 1.0 state is my building block. And finally, this is my state store name. So when you specify the state store in our configuration file, you specify the name. So you have to pay. So maybe you have multiple states. One state is communicating to Redis, one state is communicating to some other state store. So you specify that, you specify the target state store by specifying its name. And this is the key. So this is basically a key. If I run this URL, it's a GET request, which will return me the value for that particular key. The second is for invocation. So if I have this Dapr running on locally, I specified invoke, that means I'm using service to service invocation. So between if my front end wanted to communicate to any of these services, I can even directly call this guy localhost 3500 invoke, and this is my app name, the method, and the routing path. So and it will invoke my service, which should be running as a Dapr, which should have a Dapr sidecar is attached to that application. In order to set up Dapr on your machine, you have to install Docker, right? So this is a prerequisite. If you are using Windows, you can install Docker Hub for Windows, and it should be switched to Linux containers, right? So it works with Linux containers for now, and then you have to install Dapr CLI. So this is the command line tool. You can install it with PowerShell, or for example, if you are going with Linux, you can use wget command, and there are other commands for Mac and other operating system as well. And once you have the CLI installed, you have to run this command Dapr init, which actually download all the binaries of Dapr runtime and configure it on your system. So these are the three things you have to set up if you wanted to play around with Dapr. Now I have a quick look into how we can use Dapr. So I have a simple MVC application. It's a .NET Core application. In .NET, you can just run the application using .NET Run, right? So this is the CLI for .NET. Right, so this application is working. I can easily access this application from here. I go localhost 5000, and it will give me my application, right? So this is my application, a basic scaffolded template of .NET Core application. Now, for example, if I wanted to run this with Dapr, what I will do, I will run this command Dapr run, right? I'll specify the port app ID. I can name any app, MVC app. I specify the app port, which will be 5000. This is the HTTP port. And then I can specify the command, which is .NET Run. So this is the syntax for attaching Dapr as a sidecar instance to your MVC application. So you have to specify Dapr Run, app ID, MVC app port 5000, and .NET Run, the actual command which spin up my ASP.NET Core application. Right, so this is the HTTP port through which I can access any of the building block. Let me just see what is the port number, 63076. 63076, and this is running now. Now, if I go back here, I can use the Dapr URL, which is localhost 63076. I think this is the one, version 1.0. Now, which particular building block I want to use? I want to use invoke, because I want to invoke the service from Dapr. And what is the app name? App name is MVC app. Okay, then which method I want to use? I want to access this method. Let me just verify the port number. It's 63076, 63076. That's it. You see, I was able to reach this application. And for example, if I wanted to 63076, I wanted to go to any other routing URL, I can just specify like this, and it will land me to that particular page. So this is how easy it is. Now, here I have used just a service invocation. Now, if you wanted to use state management state store, or you want to send some publish a message using PubSub, or you want to use some binding, or you want to send some telemetry to application side or other resources. So we have around 7 building blocks there. So you can use any of those building blocks, and you can just consume it using this API. So this is my HTTP API, and you can just consume this guy right using following the URL pattern for that particular building block. So this is for service to service invocation, and this remains the same. This is my 3000. What is my HTTP? Sorry, my port in that case is something which is dynamically assigned. I can also specify that port if I want, and I can also see the running instances, running sidecar instances by running this Dapr list command. All right, so one instance is running, and it's showing me the HTTP port, the gRPC port. If I wanted to specify my own port, you can use -- port switch to specify your own port as well. So that is also possible. So I'll just stop this thing now. Right. So any questions so far? Okay. question, you can just type it on a chat window and I will answer it. Okay, so let's start. What are the building blocks now? We will explore some more building blocks. So these are the building blocks when you are that you can use with Dapr. So when we are building microservices architecture, we are mostly using all of these building blocks. So for example, we wanted to store something in cache, we can go with state management. With microservices architecture, we wanted to implement async communication, so we can go with publish and subscribe model. Sometimes we need to listen to some events, so we can go with bindings and triggers building block. Sometimes we have to implement a design pattern, actor design pattern, we can go with actors. For telemetry, we can use distributed tracing, and for secrets, which is primarily used to save something or read something from the save storage. So in Azure, we can use Azure Key Vault to keep some sensitive information, some sensitive values there, and we can use this particular building block to read or write value from those secret save storage. Now let's go through one by one about what service invocation is. This is what we actually saw. So for example, if your front-end application wanted to communicate to your service, this is the endpoint they can use, HTTP localhost 3500. This port can also be dynamically assigned if you're running an on-prem. And this is the version which remains as it is. This after version, whatever you specify will tell Dapr the specific building block you are opted to use. Then the name of my app, this is card service, so I can name each service with different I can give names to different services. And this is the method, which is basically I specify that which particular method I want to call out for this card service. So this is the standard endpoint you can consume to communicate to any service deployed anywhere. And this is a post request, so we are sending some JSON payload, and this Dapr receives this request and then internally make a post request to our card service and pass the same data which is received by the front-end application. So this is what service invocation is, and this is what we saw in the previous demo. The second thing is state management. So for example, if your application wanted to keep something in the Redis or any of these store services, right? So it could be Redis, it could be Cassandra, it could be Cosmos DB, AWS Dino, whatever you can name it, you have it. You can connect to any of these sources, and you wanted to make a you wanted to save some key value pairs in any of these storage. So instead of using these storage libraries in your application, you just need to use Dapr and you configure these state stores. I will show you in the next demo how you can configure it. It's a very simple configuration file there where you can actually specify your state store connection strings, and then you can just make this call to this endpoint, which communicates to any of that store as it configured in your application, in your configuration file, and send this data in a post request. And once once the post request is successful, the data will be written in any of the store which is configured. And same, you can actually read the data using the get request. You specify the state, which is my building block, store name as configured in the configuration file, and planet is my key. So here, if my planet was the key, so if I specify the key here, I'll get the complete value for that key, which is a JSON string, right? So this is how you can use state management. These are the implementations currently exist for state. You can keep it to Redis, SQL Server, Cosmos DB, PostgreSQL as well. When we talk about publish and subscribe model, so the publishers are producers who basically publish some messages, and the subscribe, and they don't know who are the consumers, right? So it could be one consumer, it could be many other consumers as well, and the consumer didn't know who is the publisher. So they basically share messages over a channel, over a queue where they publish those messages, and the consumer actually listening to those queues or topics to read those messages and process some work. So if your card service wanted to communicate to some other service, a shipping service, they can publish that message to Redis. And since your subscriber, your shipping service is basically listening to this Redis queue, it will get the message and process that message or do whatever it wants. So instead of having a direct communication from card service to shipping service, we can also orchestrate this call using this Dapr, where we can publish to any Redis queue and then subscribe to it. Now, suppose if you don't have Dapr in place here, for your card service, you have to use some Redis library to send that message to, or to publish that message to Redis. And on the subscribing service, you have to use some library to connect to that Redis service to get the message. Now, if that library, if for example, the underlying technology you use does not support Redis, there is no available libraries to connect with Redis, so you will be stuck in that scenario. So Dapr actually helps you and address these challenges that you just configure it once and use as many sources as you want. Okay, so this is another building block for input for bindings, right? So you can trigger something. So for example, if some message arrives at event hubs, Kafka. So these are some tools to implement event-driven messaging system. So you can publish these messages to Kafka, Event Hubs, Redis. So this is the Kafka native on-prem tool. You can say on-prem tool, or you can also go with Event Hubs, and Event Hubs today also support Kafka protocol or Redis. So any of these sources you can listen to it, and then you get the message. Whenever the message arrives here, it will trigger this particular endpoint, and then you do whatever you want. You can also publish endpoints from your application to any of these sources. For example, I wanted to send something to my database, so I can specify the data, and then this is the JSON specific. So when you're sending the message, you have to actually specify the specific JSON schema. So this is the schema for sending the message. So you have to have a data as a key, and then whatever you provide will be part of the JSON, will be part of the actual data content. And then depending on which sources you are connected to, if you wanted to send something to Cosmos DB or a DynamoDB, or maybe if you wanted to publish some events to Event Hub, all this can be done with this post request. This is for distributed tracing and diagnostics. So OpenSensor is basically Google initiative, and this is used to connect or to this service is basically pull all the telemetry information from your application, and then it can save it in any of these sources. So it could be Azure Application Insights, Datadog, Instana, Jagger. You can name it, you have it. There are many more sources. You can just connect it easily, and you just need to update. You just need to specify one configuration file to connect to that particular tracing or diagnostic source, and you can send all these telemetry to that particular source using Dapr. So Dapr provides you this distributed tracing building block, which you can use. These are the supported bindings which are currently exist. You see that most of them are experimental. So you can go with Kafka, RabbitMQ. This is some generic libraries available. So when you when you define the bindings or when you define the components, so you have to specifically define the type. And we'll see in the next demo what are types. So you have to see this particular type, and then you can get the exact schema, what specification you can specify when using that particular type. So if you are connecting to Kafka, so there is a specific type such as Kafka, and this will be giving you the complete specification that you have to configure to use or to use a particular building block to connect to Kafka source. If you are using event hubs, you can go with event hubs. I have in the next demo, I'll be showing you the event hubs configuration file. So I will show you what I'm specifically talking about, the type and the component specification. And there are other sources as well. Like for example, you want to use something for Google Cloud Platform or Amazon Web Services. All these bindings you need to first see, like what are the configuration, what are the specification for these bindings are, and then you can easily configure it and bring it to your application. Instead of using these sources, libraries in your application, you just configure it and you can consume using Dapr, HTTP API or gRPC API. And same goes with secrets. So with secrets, you can also use this endpoint. You see the standard is pretty much easy to follow. It has the local host 3500, which is your Dapr API, and then after every version there is a building block name. So if you are using invocation, you can go with invoke. If you are using state store, you can go with state. If you are going with publish, you can go publish. If you are sending something to secrets or reading something from secrets, you can specify secrets, and then you specify the name of that secret store. It could be Azure Key Vault or Google Key Management, many others. And then this vault is basically your vault name and the key which you wanted to read, right? So if there is a key stored in this Azure Key Vault named as my secret, so if you make this GET request, you will get the key value as super secret, whatever it is stored in any of the sources. You can easily retrieve it using this GET operation. So let's have another demo on how we can use different state store and event hubs. So I will first show you a simple code. So this is my node application. If you see this node application, I have different methods. I have actually created, defined different methods to perform different operations, right? So if I show you this event hub sample, here what I'm doing, I have exposed a post method, a send message. So from my application, if I call send message, internally it will now this message what this message is doing, whatever data I'm passing in the request, I'm just sending it out to my event hubs, which is basically configured on Kafka protocol, and I've created one topic as sample topic there, right? So instead of using event hubs library in my node application, I'm just making this URL. I'm specifying the local host, Dapr port, whatever the dynamic port assigned to my application, and the bindings. And bindings, this is my, that means this tells that, okay, I'm going with the bindings block, and this is the name of my binding. So if I open this guy, this is my component. So when you run your Dapr, when you run your application with Dapr run, it actually creates a new components folder, and then you can add all your YML files related to those specific building blocks. So if you see this component, so this is just if you have some understanding on Kubernetes. So in Kubernetes we can create components. So this has the similar schema. We have API version, kind, metadata, and spec. But you see that this metadata contains the name, which this is the exact name events hubs output, which I'm specifying here in the URL, right? And in the spec section, this is the all specification I have. So this is my event hubs endpoint. This is my topic where I wanted to write it to. A published topic is this, my username and password, and all these connection strings. So this is the only configuration you have to do for each building block. And then you can easily consume it by making this simple HTTP request. And then it will take whatever I have passed, and I'm just passing it to my event hubs, right? Another example is I will show you is I wanted to save something in the state store. So I have exposed this new order method, which is taking some data, and I'm just passing that data to my state store. So state store URL is basically over here. So this is my state store URL. It's a similar state store URL as we saw, like this is following the same standard URL pattern for Dapr. And here I can specify the state that tells Dapr that, okay, I want to go with the state building block. I want to use a state building block, and state store name is your state store, which you have configured here. So my name is state store. If I change this name to something else, I have to specify this here in the URL, and then it will connect to my Redis cache, which is also provisioned on Azure, and it will send my message, or it will write a key value pair on my Redis cache on Azure. And in order to grab that information, I'll just specify the key, which is order, and I'll get that key right away. Right. So this is some basic example of how to use any of these building blocks in your applications. Now let me start a node app. I'll go to cd node app, and I'll just specify this URL. Sorry, this command. So what I'm doing here, I'm running my Dapr. I'm stressing the app ID as node app. My app is listening around 3000. Now this is port. So if you wanted to explicitly mention the port for your Dapr HTTP, you specify that double hyphen port, and you specify that port right away. So you can consume or invoke those services right away from this port. npm start. So this is my command to spin up my node application. Log level, if you wanted to put all these logs for tracing and for if there is any exception, so it's easy for you to troubleshoot. And then you have to specify this components path switch. So my components folder where all my components file resided at, I have to specify that components path folder, and I can just run this guy now. So meanwhile this is working, I've also created one consumer client on .NET. So I'll just run this guy as well. So this application is just basically connecting to the sample topic on Kafka, and when I publish messages from my node app, it will be printed here. It will be printed on the console window here. So in order to send this message, I will go first of all I'll just see that my application is working fine. Yeah, it's working fine now. So I'll just go back to my Postman and I'll submit this message by making this send message call. Right, so if I go back to my console service, I got this message, right? So this is how you can publish. So I publish it to my Kafka topic. My Kafka topic is there on Azure. So if I go back to, like, this is my event hubs, which I provision on Azure. And I can show you, I have one event hubs, a topic I created as sample topic, right? So this is what I configured in my YAML file in the components folder. And it so my in the Node app, I didn't have to use any event hubs SDK. I just used Dapr. I just run my application using Dapr run. And prior to that, I actually configure these components and it connect my Node application to this particular resource on Azure and send that message which is received on this console window, right? So this is one thing. Now we will see the if we can also invoke this directly by using the same endpoint. So if you wanted to communicate to that event hubs directly, you can specify this endpoint. Of course, the JSON will be the same because this is the actual schema for JSON. You have to specify a message and the operation you want to create, right? So here I'm creating a new message. I can also use the same thing and I'll get this message printed right away. So this is one thing, and you can also now another thing is, like, for example, in my Node application, I've exposed one new order method, and this new order method is basically what it's doing. It's doing nothing but using one building block, Dapr building block, to send a message. Right. So this is what the new order method, which the API which I exposed, new order, is just taking that order and making a post request to the state URL to save that information in a Redis cache. So if I wanted to consume this message, I'll just specify this JSON string in a request body, and I'll just send it out, and I can retrieve this from the URL, which is wait a second. Yeah. Right, I got the message which I actually posted to Redis cache, and Redis cache is also provision on Azure. As you see, this is a Redis wrapper which I provision on in Azure, and it's getting the data, and then I can read it. So this is how easy for you. You can integrate with any application of your choice. For example, you are currently working on Golang, and that does not support some wide range of libraries. You can go with Dapr, and this is the two demos that we saw. And if you see the component configuration, is similar to how we define components in Kubernetes. Because when we talk about microservices needed to be containerized. They can run inside a container orchestration platform, and Kubernetes is one of a widely adopted platform for running your microservices workloads on cloud or on-prem or any other cloud platform as well. And they all works in the same way. Okay, so that's a quick demo about how to use different building blocks. Any questions? Okay. Okay. I can share that sample code for .NET applications. Yes, I can do that. I will share it on the meetup probably on the. I will check with Hassan, like, if it can be shared. I will share that sample code for .NET application as well. In order to integrate to app inside, we just update configuration in ASP.NET. How does Dapr help us? Yeah, so actually Dapr provides you a building block for configuring those sources. So instead of using application site SDK in your ASP.NET core, for example, you wanted to send some custom telemetry to application site, right? So you have to write that, you have to use application site SDK to send the telemetry information. So if you are using Dapr, you just need to configure it, and then you can use HTTP API of Dapr to communicate to that particular source. And it's not only application side. Today you are using application side, tomorrow you want to use something else. So you don't need to change or modify your application code, just need to change the configuration, and that's it. Okay, what else we have here? Any resource from where can, yeah, I will share the resources. In order to start with the Dapr, we have a complete GitHub site where you can actually see the lot of documentation, presentation, everything is there. You can just have a look after. I will be sharing that your link shortly. during the end of this session. By the end of this session, I've missed half hour. Is it possible to get? Yeah, we'll be recording these sessions, so you can. We'll be publishing these videos on YouTube, so you can get it there as well. Yes, it can interface with Microsoft SQL Server database as well. I showed you, I think, previously in the slide. Okay. Okay, so let's continue. Let's have an overall architecture about what Dapr looks like. So this is what Dapr is. So if we have one service A and we have one service B, and Dapr is running as a sidecar to the service A, and another instance of Dapr is running as a sidecar with service B, and you can use anything in this particular picture. Like you can go with for observability, you can use application side Prometheus. You can use the building block for distributed tracing. For different bindings to receive messages and to send messages, you can go with bindings. To send messages or to save some stores, state store, you can go with any of these sources. And for pub sub messaging, you can go with this. So this is the overall architecture of how Dapr looks like. It also provides you certain SDKs. So these SDKs are available for some of the languages like Rust, C++, Node, .NET Core, and you can use this SDK to implement actor service pattern, because of course you need to implement some interfaces and you need to create an actor service and actor client. This topic we'll be sharing. I will be sharing this. I'll be sharing more on the actor pattern probably sometime later. This is something very good, very highly adopted pattern when we are building microservices. However, these services can internally communicate over HTTP or gRPC API and connect to any sources as you want. Now let's talk about Dapr hosted Kubernetes. When we talk about microservices, so we cannot resist talking about Kubernetes or any container orchestration platform. So far we saw that, okay, how we can run Dapr locally. It's very simple. You can just Dapr run and then it spin up a new Dapr instance, attaches with your application, and then you can consume or you can use those building blocks by using any protocol, HTTP or gRPC. But how, for example, if I wanted to containerize that application and I wanted to deploy it on Kubernetes cluster, how can I do that? So this is Dapr also supports you to run your Dapr sidecar instances with your application on Kubernetes cluster as well. So in order to do this, you have to, first of all, Kubernetes, you have to initialize Kubernetes. You have to connect to your Kubernetes cluster first, and there is a special process. I won't be specifying how you can do it, but if you have some understanding on Kubernetes, you can connect to that particular Kubernetes cluster, whether it's on-prem or cloud, and then you have to run Dapr init Kubernetes, right? So it will basically configure 4 components. This is Dapr actor placement. This is one container. Dapr sidecar injector. This is another container. Dapr S entry and Dapr operator. Dapr placement is basically used for actor service pattern. If you have actor services or actor clients running, you can. This is basically used for actor placement services. This is used if you have application configured to run with Dapr sidecar. So this service actually inject that Dapr to your application, right? To that particular pod. This is for some S entry is basically used to bring some logging information and some telemetry information for your container, for your Dapr instance as well. And this is for which basically operates and connects to any of the sources, any of these components. And inside one pod, if you see the Kubernetes architecture, we deploy a container that runs inside a pod, and one pod can have multiple containers running as well. So this is the concept that you will experience if you configure your container to run with a Dapr runtime. So inside one pod, there will be 2 containers running in. One is your application container, and the other container will be your Dapr sidecar. And your application will be communicating to this container either over an HTTP or gRPC protocols. So right. So this is but you have to, of course, when you containerize, when you deploy your containers to Kubernetes, you have to specify some configuration, and that I'll be showing you shortly. We already discussed this. So this is the command you have to initialize Dapr init and --Kubernetes, and then it creates these 4 pods on your Kubernetes cluster. So let's have a quick demo for this one as well. So I have actually created one application on I've deployed one application on Kubernetes. So I'll just show you first what it was. So the application is this Node Cube app. If you see this pod, in one pod, I have two containers running. So if I just describe this pod, I run this command kubectl describe pod and specify the complete name of that pod. So this is, if you see this config, if you see the complete details, there are two containers running. So this is my first container, which is currently I push it to this particular registry. This is my private container registry on Azure, and I push this image on as with this name Node Cube app version 5.0. And if I scroll down, I can see another container which is running as Dapr container. So this is my sidecar container, right? And from my application, I can easily consume this container over HTTP port. And if I wanted to see like, okay, which is the port for my Dapr sidecar? So this is 33500. So if my application wanted to use any of this building block to this container, I can make a request HTTP localhost 3500 version 1.0 block name and then the rest of the configuration. And then I can just use that block. But not only this, you have to also deploy your components to Kubernetes. So if I go and search kubectl get components, so these are the two components running. So event hubs output, which is the component I showed you in the Node app, which is basically connecting to Kafka to publish some messages, and the state store component, which is connecting to Redis, Azure Redis cache to save some information and to store some information. To read some information and save some information. And then I can also go to get services because I also deployed services. So I can consume this endpoint from my public IP endpoint. So you see that this is my application endpoint and I can just consume it using 9901 to invoke any building block or to perform whatever I want. Right, so this is what the configuration looks like. Let me show you what the what configuration actually you have to define when you are creating a deployment. So in Kubernetes, we can define deployments, right? And this is this template actually holds the pod configuration, right? So in this pod configuration, you have to specify these 3 bits. So you have to specify the annotations. You have to specify, okay, Dapr, enable Dapr to true. What is my application ID and the port which will be used by the application. So these are the 3 things you have to specify. And if you have Dapr initialized on Kubernetes, you can easily deploy your containers with Dapr as a sidecar running in the same pod, and you can use the same building blocks as we saw in the local on-prem server. So that's all we have for this today's session. If you have any questions, let me know. Otherwise, let me share some uh, uh, resources. So if you wanted to learn more about Dapr, so we have few videos that you can check out as well. Plus, you can also go to github.com/Dapr community, and you get a huge set of documents, presentation, videos that you can actually download, or you can review those documents and you can play around with Docker with Dapr as well. And uh, this is the community link. If you wanted to get involved and you wanted to participate as an active contributor, you can go to github.com/Dapr, and then you can participate and you can contribute on this particular framework. So that's all. Let me know if you have any questions, anything. Your feedback is also important for us. So let me know how do you like this session, and I'm open to take your questions as well. If there are no such questions, so I would hand it over this to Hossam to close out this session. Hossam, are you there?
Yes, I'm there. Thank you, Ovais. Shall I wrap up?
Yes, please.
Right, I'm starting to screen share a few things. Yeah. All right. So yeah, thank you again, Ovais, for your valuable time and sharing your experience with our community. And thanks for everyone who joined us today. I would like to encourage you to take the Reactor survey. And this session has a unique code. It's 7791, and you will need to use it in the survey. I pasted the link in the Q&A as an announcement, so you can check it. This helps us get feedback about the topics that interest you, and we can also include that in our future programming. So I highly encourage everyone from our community members to take this survey. The second thing I want to share is a few interesting sessions that are upcoming this week. So tomorrow there are two interesting sessions. One is on adding AI to your applications in the easy way. So this will cover the cognitive services where you can do cool things like detecting text in pictures, translate text, and even provide sentiment analysis. So in this workshop, we will learn how to use the cognitive services and how we can actually use and add pre-built models to an application. So this is tomorrow at 4. And at 7 o'clock local time, Abu Dhabi time, we have a session on Power BI introduction. This will be starting from the very basics of Power BI using a task list as a data set. And we will be covering connecting the data, performing some transformation, tidying up, modeling, adding relationships and calculations. So this will be very interesting for you if you are interested in Power BI. This will help you get to publish the report to a Power BI service. And on Thursday, there's a session on the bot experience. In this session, we will talk about the process of creating a bot, demo how to best communicate with users and understand what users are trying to tell the bot. There are more sessions, of course, this week and also in the coming week. You can check out the calendar for more sessions. I just wanted to highlight these sessions for you to continue the journey. And also, I want you to continue the journey and subscribe to the newsletter. The newsletter is a monthly curated content for developers containing the latest articles, documentation, technology, events, opportunities, and chances for you to connect with developers locally and online. And similar to that, there is also the Azure developer community, which I highly encourage you to join. And also you can explore the Microsoft Cloud Society to find more learning opportunities and webinars to learn from. And that's it. These are the links to our YouTube channel. We will have this session also posted there in a couple of days, very shortly, I would say, and you can still be able to access this session on the same link for the next probably 16 hours. So if you miss some part, you can review it and also subscribe to the YouTube channel to make sure you can watch the session on demand alongside other sessions that we're doing in Abu Dhabi and across all the reactors globally. There are so many valuable sessions that you can find on our YouTube channel. Thank you again, everyone, for joining us today. And thank you, Ovais, for your time today. And that's it. Stay safe, everyone. See you.